Hello dear student. In this video we will start third chapter, that is about the system board. So here we will learn types of system boards, system clock, CPU and chipset, attribute of CPU and chipsets only, Pentium, and which are the different competitors available with this Pentium, ROM, and mainly the BIOS information that stored in the ROM, flash ROM, one type of ROM as in a flash ROM. So we'll see what is the meaning of it and what are the features of this flash ROM, where it will be used. Then next point we will learn RAM, that is about your temporary memory, random access memory, and different types of RAMs. Onboard ports, which are the different ports are available with the system port, that is with your motherboard. And the last point, CMOS chip setup. In that practical already we have seen that CMOS battery setup and which are the different options that are available within the BIOS for CMOS configuration, and how we can set this CMOS with the for chipset. Now the first point, right now we will see the first and second one, and also the CPU. So system board, here we will see which are the different types of system board. System board mean you know that it is in a motherboard. So this motherboard will be having the different types. Mostly it includes AT and ATX as in a type. AT it is an older one and ATX it is a new type. Now this AT system board, it has having power connection for 5 and 12 voltage lines. Now these according to its the shape, different shapes of this motherboard. This motherboard also called as a form factor of that motherboard. So that form factor of the motherboard will decide the shape of motherboard and power supply, power connections, cables. Now we will see the which are the different types of motherboards. One AT, another one baby AT, third one ATX, and fourth one mini ATX. So these are the four major form factors types of system board. Now AT, here you can see the description is that it is an oldest type of system board. It uses P8 and P9 power connections, and its major size is 30.5 centimeter to 33 centimeter. Second type of system board, it is a baby AT, which is a smaller version of AT, as its the name is indicating the baby AT. Pins are the same P8 and P9 pins, and its the measures around 33 into 24 centimeter. Next one, ATX, developed by Intel for Pentium systems, and it uses 20 pin power connector, and its size is 30.5 into 24.4 centimeter. Then mini ATX, this is a smaller version, compact version than ATX, and its measurement is about 28.4 into 20.8 centimeter. So these are the types of system boards. Now this is one example that how exactly this ATX system board looks like. So the current system boards are the ATX system boards. These are the different components are available on the system board. System board, it is nothing but your motherboard. You can see here CPU fan and heatsink, then CPU socket, connectors for integrated peripherals. This is CMOS battery, round circle you can see here. This is a 1 rupees coin like structure that you can remove, and again you can reset it. PCI slots, PCI bus slots. This is South Bridge, and one you can see here, North Bridge at this side. So South Bridge, North Bridge, these are the chipsets for making connections and transferring data for different devices, different components. Yes, North Bridge to this side. Then IDE connector for your hard drive. Then DRAM memory slot. This RAM we will study having two types. SRAM and DRAM. SRAM static RAM and DRAM it is in a dynamic RAM. So this is a memory slot and 20 pin ATX power connector. So just we have seen ATX is having a 20 pin connector, means there will be having a 20 pin slots for connecting to power supply SFPS. Next point we will see that is about the system clocks. Now system clocks, you know that every computer, every personal computer, it is having its a clock system. And what is the use of clock system? It is used to give the time, correct date and time. That is the use of the system clock. Now what exactly the system clock? This is an electronic circuit which counts the signal from processor clock, an independent oscillator. So it is in a circuit and it is used to count the number of oscillations, number of vibrations, signals count from the processor. So processor, it is also having the clock, processor clock, and parallelly another system clock is running. So process, difference is that when suppose a process execution stop, then that process clock will stop, or suppose there is a failure in the execution of any kind of process program, then it will stop, that particular process execution stop, and clock also gets stopped. But here the system clock run persistently without stopping. So that's why it is giving a correct time. So on this computer, you can see here, you get a correct date and time and the correct current time as per your location. Now this clock, actually it is a microchip. It is a chip which has been stored on your motherboard, and it's a system timer. It is a continuous pulses that help you to identify the correct date and time. Now, for processor clock, the clock speed can be measured like this: 1 megahertz or 2 gigahertz, like that. 1 megahertz means is a 1 million cycles per second. 2 gigahertz means 2 billion cycles per second. So in that way, your operations will be get performed. Means for 1 second, there will be the 1 million cycles will be get repeated, or 1 gigahertz means this billion cycles will be get repeated. Now here just a pictorial view of system clock, that it is an oscillator and it is providing you date and time. Here in the system clock, here you can see the instruction data. So irrespective of the information that is running or the processor running the process, it will calculate continuously your date and time with the help of these different cycles and with the help of these oscillations. So that is about the clock. Third point, that is about the CPU and chipset. Now, what is a CPU? It is very simple one. CPU, it is in a central processing unit. Now, what is the use of central processing unit? It is used to process the information. It is used to process any program. Now, it is also called as the brain of the computer because it is performing the main functions of your computer. Suppose I am requesting any data from the server. I'm opening a Chrome. So that is one process. Now this process should be run by the CPU. For example, suppose you are logging to the Gmail. So this Gmail login or login to Google Docs. So for that, you have to provide that username and the password. So that data will be sent to the server. Now this processing should be done by your computer also. So that opening that Chrome, then you are writing something into the URL, and that information should be sent to the throughout the network and to that particular web server. So that all this processing for every process will be carried out with the help of the central processing unit. So for every processes, whatever the data processing is required, passing the data, then printing that result data to the and sending it to the user back, all these operations will be performed by this CPU, that is a central processing unit. Now let's see this diagram. Now this is very typical diagram. In first year also you might have learned this one, this picture. So you can see here input unit, memory unit, control unit, arithmetic and logic unit, and output unit. So this input unit will give the input to the CPU, central processing unit. What it contains? CPU contain memory unit, control unit for controlling the data, and arithmetic and logic unit for processing the arithmetic operations and the logical operations. And then this output will be sent to this output unit. So this input unit, it is giving data, and it will be processed by, it will first of all, it will be loaded into the memory unit, then it will pass to the control, then arithmetic unit, and then again this data will be passed from arithmetic to control to the memory, and then it will go back to this user for printing the data, that is for the output unit. Now here, memory unit, it is used to store the data temporarily when it is going to process. So that is your RAM, random access memory. So it depends on your speed of RAM and the latest RAM that you are using. It is used to store the data and the instructions required for processing. Also, it stores the intermediate result of processing, and it will send the result, final result, to the output unit. So input and output units are transmitted through the main memory. Now, what is a control unit? This control unit, it is used to control the operations. Now, control the flow of that data and instructions. So it will send data one by one. Coordination between and synchronization between all data that will be done by this control unit. And the processing of actual data will be done by the ALU, that is the arithmetic and logic unit. Arithmetic will do the arithmetic operations such as addition, subtraction, multiplication. Even some mathematical complex operation will be done by this arithmetic section. And logical sections will perform the logical operations such as comparing, selecting, matching, and the merging of data. So arithmetic and logic unit will calculate all this result. It will pass to control unit, and control unit will pass to memory, and memory will pass to the output unit. So in that way, the CPU will work. So I think you understood about the CPU. CPU, central processing unit, containing memory unit, control unit, and arithmetic and logic unit. Input data, first of all, will be fetched to memory, RAM. It will be loaded into RAM. RAM will pass to control unit. So it will handle that how exactly data should be passed. The synchronization and coordination will be done by this control unit. Two, it will pass to arithmetic unit. Arithmetic unit do, and logic unit will do the operations. It will calculate the result and send back data to the control, and control will pass to the memory, and from memory to the output. In that way, it functions. So we learned about types of system boards. Clock, system clock, just for calculating the clock. So it is a parallel clock like a processor clock, but it will not stop, and it is one electronic microchip. It runs with the oscillations and the frequency same as a frequency of your processor clock. And third one that we learn about the CPU. Now in next video we will go with this chipset attribute. Now we'll stop here, and thank you.